Next up is to test our dumpy level for a collimation error. What we'll do is we'll set up right in the middle of a 30-meter baseline, measure your backside, which is your point of origin, and also measure a forward side. After that, we'll pick up our dumpy level, move it closer to our backside, let's say of half the distance, measure our backside again, and then measure our forward side again from the same spots. So how we do ensure that we measure it from the same spots? By leaving our change plates on the two different locations.
Welcome to another dumpy level theory training session. In today's training, we'll discuss more about the collimation test, how to do a collimation test, calculating the collimation error with a physical example, and then correcting the collimation error. Let's go into more detail. So, how do you actually do a collimation test? The first thing you do is you take two change plates. Why change plates? Change plates allow you to set up on the exact same position without there being any vertical movement. So you can either knock in a peg at two different points or place a nail in the ground, but it has to be a point that you can come to with the exact same Z value. So in this case and in the video, as you've seen, we've taken two change plates. We place them 30 meters apart. Then the second step is to take a measurement on the first point. Let's call it point A. And then take a measurement on point B or point 2. The third thing you do is you move closer to point A. You take another measurement on point A and again on point B. It's very important also to consider when doing your collimation test to try and do it on a level ground or as level as possible. So let's look at the next slide, which is calculating the collimation error. So when you place your dumpy level in the center of point A and point B, which is approximately between 30 meters or a 60 meter baseline from each other, you'll measure point A, write down the reading, measure point B, write down the reading. After that, you'll move your dumpy level closer to point A. Take another reading on the staff at point A and another reading on the staff at point B. You'll calculate the difference between A and B of the two subsequent setups. If there is any difference in height between the two readings, it means you do have a collimation error and you have to do an adjustment to your dumpy level before you proceed with measurement. Let's look at an example of what we have just mentioned. As you can see, we have point A and we have point B, and in the middle of point A and B, we have our dumpy level. You'll take the reading of point A, and let's say it's 1.530. You'll take the reading of point B, which might be 1.235, and then you'll subtract A minus B, giving you a height difference of 0.295. You'll move your dumpy level closer to one of the points, A or B. In this case, we moved it closer to B. You'll take another reading on point B. That will be 1.230, and another reading on point A, which is 1.556. You'll subtract A minus B again and get the height difference. In this case, the height difference was 0.326, which is much more than the first reading of 0.295. This shows me that there is a collimation error in my dumpy level. And exactly how much is when you subtract the bottom one minus the top, and you'll get an answer of 31 millimeters. So we need to do a collimation adjustment of 31 millimeters in order to be sure that our collimation error has been resolved before we can start to work. In the perfect world, we actually want to see that these numbers are exactly the same. The difference between these two B measurements must be the same, as well as the difference between the A measurements must be the same. If they are the same, this means we don't have any collimation error. And the same when we subtract A minus B and we get to an answer of, for example, 0.295, we want the same difference to be 0.295 when we move our dumpy level. This will show us that our dumpy level does not have a collimation error and we don't need to do any adjustment. So let's look at the method to adjust for your collimation error. When you take your dumpy or optical level, at the eyesight at the back, there's a small cap that you can unscrew. Once you unscrew the lid, there's a small screw on top of the eyepiece. When you turn this with a screwdriver, it will move your crosshairs up or down, and this will adjust for your collimation error. So what you'll do is, the amount of adjustment that needs to happen on your dumpy level, you look at the staff in the distance to the specific measurement you want and adjust the top of the dumpy level to that specific reading you want to make sure that there is no collimation error on your dumpy level. And it's as easy as that. Just remember to redo the collimation test after you have made adjustments to make sure that the adjustments that you have done are in fact correct. Awesome. Thank you for watching. See you in the next one.